All right, cool. I want to talk about data visualization today. Ember is fun. Everybody likes Ember here. I don't really have to sell anybody on Ember, which is nice. But D3 is a little bit different. There's kind of a fun crossroads between Ember and data viz, and hopefully you guys learn a little something. So let's just jump right into it. But first, some buzzwords, or a brief overview. So data kind of gets a little bit of a bad rap. So I want to talk about some of the things that I think are important about data visualization, specifically with respect to Ember. OK, cool. So socially, we're at the point where we can kind of record anything. Quantitative analysis at a really, really basic level is not too hard. You know, there's some trivial things you can do, and there's some more complicated things you can do. A couple examples are like the Reporter app. iOS app lets you record any kind of data you want. You know, you wake up in the morning and it'll say, how did you sleep? You record that. You look at it over time. You can start pairing that with what kinds of things did you eat today, or how late were you for work, which for me is always pretty relevant. You also have things like city open data policies. I know Boston has one. City of Toronto has a great one. And finally, 1,000 Genomes is a really nice open data initiative that kind of tracks the human genome. So these are all open data policies. They let you visualize things pretty well, so long as you know how to do it. So we're going to talk a little bit about how to do that in Ember. But you know, with all these things, we're actually maybe too good at it. Twitter in general, right, which is a great source of data about mostly mundane things, very often breakfast. You know, it generates about 500 million tweets per day. That's a lot more in a day than Library of Congress has in total. And it's too much. There's just too much data for us to ever really analyze in a one-to-one way in our lifetime. It's just not something that we're going to ever be able to do with the amount of data that we grab right now. So, you know, when we aggregate it, it's not necessarily clear whether we aggregate it or not. And that's a bummer, right? Data is only valuable when it's understood. That's kind of a major premise. And I think a lot of people that just gather the data tend to sometimes overlook this. It's why we need people to organize it, and things like data journalism does a great job of drawing conclusions from the data and letting data tell a story. So here's kind of an example of what I'm talking about. This is a set of data from a paper, and it's cut off at the bottom, but there's a source. If you want to follow my slides online, I'll post a link in a minute. So this is statistical detection of something really, really important. And what it's actually the statistical detection of is election fraud. What you're going to see is there's a couple examples, hopefully this is visible enough, where you can see election fraud happening, where the percentage of votes for the winning party or person, and the axis at the bottom there is voter turnout per district. You notice that there's like a weird overlap where you can really clearly see it in the visualization, and it's not at all clear if you just look at the data proper, at least not to a layperson, which is kind of weird, right? So we have all this data, we're recording great amounts of data, and it's not always clear what's going on until we look at it visually. But that's OK, because we're going to learn how to do some really cool data viz. And that's the truth of it, right? Visualization lends meaning to raw data. Raw data on its own is interesting, but again, only when it's understood. So let's talk about D3. Just for a quick show of hands, how many people have worked in D3 before? All right, cool. So it looks about half of you. And that's good. So if you don't know D3, it's a data visualization language in JavaScript. It was written by Mike Bostock primarily. He's now at the New York Times, but used to be a researcher in data, and has lots of really great stuff. So D3 lets you basically take a document based around data, and on the web that tends to be your browser, and it lets you bind things to the DOM, lets you manipulate DOM objects. I think what most people use it for tends to be SVG, but that's certainly not the only case. Lets you do other cool things, like lets you manage state change, right? In Ember, there's all sorts of state changes, you know, your route changes. Ember handles that. Data in general isn't really great at handling what you're doing. Data is data, and you are you. D3 lets you kind of pair the two. So there's a link there that gives you a really great introduction to the library if you're looking for it. He also wrote this really great article called Towards Reusable Charts. He wrote this, I think, about 9 months after the library picked up Steam. And it goes through a lot of steps to kind of get people to build charts, graphs, et cetera, with D3 that become reusable. Code on the web is not a super easy thing, and I know that it's really, really easy to do it wrong. And the web is a lot older than data visualization on the web is. So data visualization is kind of coming into the time where maybe JavaScript generally was 5 or 10 years ago. There's still a lot of spaghetti code out there. So he writes this post, and he talks about data visualization being a little bit more opinionated. And we're all Ember people, so this sounds pretty familiar to us. He advocates for charts as being closures with getter and setter methods. And there's a link to read the article if you like. So here's what it tends to look like. What he asks people to start doing is a chart that is defined in this kind of way. And if you take a look at it, you'll see the definition. It's a closure. It has getters and setters. If you pass something into it, like what we look at the call at the bottom, you're going to get a chart object back that you can ask for chart.width later, and it will return 500. You can get chart.height, and it will return 250. And if you didn't want to put those values in, you'd get the defaults that are there instead. But that looks kind of familiar, right? So that code ends up looking an awful lot like something like this. This is an Ember component. This is right off the Ember.js website. It's the way to grab a gravatar. So not a chart, but still effectively a closed function that has getter and or setter methods, depending what you want to put into it. So Ember components generally adhere to the principles of reusability. So the definition function that acts as a closure, default property declarations, and the ability to create any number of instances with the default or variable properties. When you take that component, you can just keep repeating it as needed. And then .property allows for easy reconfiguration as needed. So it's actually going to listen when new things happen and reorganize itself, add new instances, stuff like that. A quick word on web components. So web components are W3C standard element. It's still kind of in the working draft stage. So there's still possibly some changes to be made to it. But Ember components are available today. You can start using them right now. It's actually a really great way to start moving forward with respect to components and the componentization of HTML. It's frankly, I feel every time I use components that I'm a little bit ahead of the game where I was before I would use it. It lets you kind of modularize some things still within a really nice framework of Ember. So we talk about Ember being a framework for creating ambitious web applications, and I want to try and say that we can also create ambitious data stories, which is a really wonderful buzzword, but it's basically just a way of letting data talk. And I want to talk about how Ember makes that really easy and possible. So let's take a look at some examples. If you guys want to follow along, you can. I'll put up the URL right now. Just go on over to emberviz.affin.io. Let's see, it's right there. Hopefully we can see that. So you can jump into there if you prefer. And we'll keep walking through. So baseball is kind of my sport of choice, and it's kind of a statistician's dream game. So I'm also a closet Detroit Tigers fan, so this is going to be really fun for me to revisit how Boston beat Detroit last year. And we'll take a look at that data. What I'm going to do is I'm going to take the data from MLB.com, and I'm going to posit it into an array, and we're going to kind of make an array controller that handles this. So I've converted it to JSON. Here's what it looks like. Nothing too crazy. We see the teams. We see really basic stats like the number of at-bats, runs, hits, strikeouts, and their average. And if we pass it into Ember as a model, we can declare an array controller to handle it. So nothing too crazy going on here. Everybody should recognize roughly what this code looks like. Cool. So in our templates, we can do some really basic manipulation, like put an each inside our handlebars template and create a bar element that has all the basic info. So we're going to, for each player, we're going to say player.name, their position, their team, so on and so forth. And we'll style it a little bit so it looks like a bar. And this will give us our first example. So at raw data, we'll just pop that open. Yeah. So nothing much to see here, but that is that data that we previously looked at on the MLB.com table, and now it's presented in Ember inside an each and handlebars. But there's not much to it. We have it, and we can sort it. We can do all that kind of easy stuff, but the presentation isn't really helping anything. Frankly, the table was better, more readable. The data was more organized. But we can make this layout more informative. We can do a lot of things to it. So right now, the only thing that we can really tell from it is the order. And if you pay attention to it, you'll notice it's an order and descension of number of hits. So the person with the most hits was Victor Martinez. Least hits was Steven Drew. So let's kind of make it more informative. Let's do more than just that. Quick note. I called these M bars before I realized that people in Boston can't pronounce the A and R thing very well. So we can call them M bars if you guys want, and that might be easier. We're going to use some familiar methods to get things done. We're going to do the first couple examples without D3, because I know for some people D3 is a little bit of a learning curve. So I want to introduce it slowly. So first things first, let's turn our players into Ember components. Right now, you might have noticed we were just kind of using these bars that aren't really componentized. It's just sitting right there inside the handlebars template. So let's start getting componenty. Cool. All right. So the way that we change it inside our handlebars template is we define the component. We just say M bar, and then we'll say player equals player. And now we kind of have an isolated element. Later on we can create either in its own component file, or if you're just doing it the real easy way, you can just toss everything in your index file. Sorry, Ember Cly guys, don't kill me. And we can start cutting out some of the extraneous bits, right? The component lets you have a couple things like tag name and class names. Sorry, another quick show of hands. Who here has written an Ember component before? Cool. All right, most of you. So yeah, there's a lot of things built in with components. Tag name and class names are pretty straightforward. There's other really nice things that we can do. We're going to use class name bindings to bind the name of the team to that player. So what you see is that instead of just bar, which we had set as the class name, we're also going to see whatever team they happen to be on will show up there. Don't use caps for your class names, kids. That's not ideal. Cool. So this gives us a couple of different options. Now we can go into our CSS and we can say if you're a bar with a class of Detroit, give you an orange background color. With Boston, give you I think it's a red background color. So on and so forth. And now we can start taking a look at what this ends up generating. There's supposed to be a link there. Oh yeah, there it is. Cool. Yeah, so this will give us our exact same chart, and I know it's a little bit bright in here, but you should be able to see that there's a distinction between colors. Boston is red, St. Louis is also red, the Dodgers are blue, and the Tigers end up being orange. So we can see a little bit more. So we're starting to move towards the point where this data is as valuable, if not more valuable, than the data that was presented on MLB.com, just in a regular table format. But we can do a lot more, right? So that's just our colors. It's pretty simplistic, and we basically have two things to determine visually. We can look at the order, again, that's showing hits from top to bottom, and we can look at the color, and that says what team you're on. You can even kind of determine a couple things from this, right? If you wanted to, you could say there seems to be a preponderance of orange toward the top, and a darker red and sometimes blue preponderance toward the bottom. If you're a gambling man, you had to look at this at a glance, you would probably say that it appears that whatever team is orange has hit better than the red or blue teams. Which is not really how baseball works out sometimes, but that's the game. Cool, but we can keep making this a little bit better. Let's actually make our widths coordinate to the number of hits, right? Any bar chart you see, if everything is the exact same width or height, that doesn't really tell you too much. So let's use Ember to coordinate width to tell us a little bit more. So the first thing we need to do is take a look at the player that has the most hits, and then say that that player's bar is going to be full width. Everybody else's bar, that'll be a proportion of that full width bar. So we need to figure out who has the most. So let's do a nice little function that Ember gives us called computed max. So the first thing we're going to do is we're going to be reading from our model. We're going to say that hits are Ember computed mapped by our model, which we looked at earlier, and we're going to map it by number of hits. That'll just give us a basic array of everybody's hits. And to determine the most, ember.computed.max. Or if you prefer, you could use underscore or something like that as well. But this will just tell us the person in this list that has the most hits, and then it'll give us that number. And in addition to passing the player to our component, we'll also pass this most hits in as max. This way, each component is going to be aware of what the maximum is. And that gives us some stuff we can work with. So now we know the maximum number of hits for any given player, and we know their number of hits. Just kind of walking through it. We need to do a couple things on our component element to make this look visual. So what we have is relative hits, and this is worth looking at. If you take it and you get that player's hits divided by the max number of hits times 100, that gives you their number of hits as a relative percentage of the most hits. And what we can do is we can say hit style returns that as a CSS string. So we just say width equals what we grabbed right here, and we give it a percentage. And what that gives us is this example. Yeah, so that's pretty cool. You see it says most hits at the top is 8, and then everybody down from there has a width that's associated with it. So that's pretty cool. In my mind, this kind of gives you a little bit more than what the MLB.com page gives you. It gives you relative width bar charts. So that's fun. It's not using D3, and you can, this doesn't necessarily have to be about hits. We can make it about any given subject, So we're going to actually talk about that next. So just kind of as a basis, we've set up our bar chart. It gives us more info than what we were looking at before, but it still doesn't really do anything. It doesn't really let the user drive anything, and that's a really nice thing that Ember lets us do pretty easily, so let's start incorporating that. So we're going to call this the user-driven data narrative, which is kind of a mouthful. But let's talk about what we're actually going to do here. What we're going to do is let the user pick what metric they want to measure on. So we did hits by default. We'll keep hits by default, but we're going to let the user set the metric that they want to cover. We'll create a quick UI element, and we will use set metric to determine what the controller should be using. What that amounts to is a bunch of buttons. They'll say hit, runs, etc. We're going to change our mapped property and our max properties, which were before reliant on hits, to use whatever we pass in. And instead of max being max hits, we say max is max metric, and the metric itself will pass into the component. Cool. And then the component itself basically works the exact same way. Instead of being specific to hits, it'll use whatever metric you want to pass in. To make this a little bit prettier, what we're going to do is put a transition on our CSS. It'll make there be a delay whenever the bars move, whenever anything moves. And this is what we end up getting. So exact same chart as before, but if I want to, I can change custom metrics to be runs, strikeouts, at-bats, or even for fun, you can do letters and name. So Mr. John Jay of St. Louis doesn't really compare to Matthew Carpenter. And that's the gist. Again, no D3, still a bar chart. Lets the user kind of mess around with the components a little bit, change what they want to change. Yeah, and that's all online. You guys can start playing with that if you want to a little bit. But that's not really using D3 at all, and that's cool. It's great that you can do these kinds of things without D3, but let's talk about why we would want to use D3 at all. HTML and CSS kind of limits us in the number of shapes we can use. There's a lot of really great things you can do with CSS, make circles really easily now. But making those and manipulating those, is nowhere near as easy as what D3 lets you do. D3 gives you a lot of things. It gives you SVG shapes, which can be manipulated pretty easily, and lets you do all sorts of kind of more abstract things other than just width or color, right? Lets you say mess with gravity or mess with charge, which don't really mean anything on their own, but once applied to an SVG element, you can start applying some identity of physics to it, right? So where charge will mean something or gravity will mean something. And we're going to start playing with that a little bit. Force-directed graphs, I'm going to show an example of this in a little bit too. It's a really, really great kind of standalone method inside of D3 or chart type inside of D3 that lets nodes, in this case our bars, act kind of independent of one another and react to one another. So I'll show what I mean in just a minute. First, though, I want to, for anybody that hasn't really used D3 or is thinking about using D3 more often, there's a bunch of really great libraries that help act as launch pads. My favorite one is called C3JS. You can check it out at c3js.org. It's pretty new. It's only really come about in the last, I'm going to say, 5 or 6 months. And it kind of helps step you into to D3. It has a lot of really great example charts. We're going to mess with a couple of them today. So we're going to take our bar chart, and we're going to leverage C3 and D3 to create custom data visualizations. So let's talk about one of the big differences that's going to come up right here. So far, what we've looked at are Ember components that deal with individual bars. So each component was called bar or player or something like that. What we're going to start doing is considering our component to be the graph as a whole. So instead of player or bar being the chart, we're going to say team, or in this case, we're going to say bar chart. We're going to kind of take advantage of some of the really nice things that Ember with D3 lets you do. We'll use a single data set, just like we've been doing before, but we're going to leverage 2 different charts with that same data set without having to split it up. We're going to provide the UI for the user to be able to filter data in and out, which is pretty nice. They can kind of select what teams they want to see and which ones they don't. Our first chart is going to combine multiple properties, so it's not just going to be showing hits at once or strikeouts at once. And our second chart is going to handle aggregated data. So we're going to do a little bit of a transform on it as it comes into the component, and we're going to make that data stand out. So let's take a look at what we're going to need to make this happen. We're going to declare a new component called stacked bar chart. And this is kind of my default method for creating anything that leverages D3. Sorry, it bleeds off the page a little bit here. There's all sorts of different component and view methods that you can use, but the one that I tend to prefer to use is did insert element to start generating the code. You could use something like on init to observe when it comes into play as well, but that doesn't necessarily give you the DOM element. Did insert element will depend on both the DOM being present, which D3 kind of needs to append to, as well as the data being ready. So we're going to declare a new C3 chart using c3.generate. And if you're familiar with D3, you can use whatever syntax you'd like there as well. We'll bind it to the stacked bar DOM element, and we'll pull in data from our controller that'll be passing in as filtered data. And then C3 lets us do some things to group our different things together. So if I want to see hits and runs and strikeouts all combined, I can do that pretty easily. And then there's something pretty interesting that I'm doing at the bottom. Within did insert element, I'm going to set something called chart element to the stacked bar chart component. This means later on inside this component I can reference this, which is good because D3 gives you all sorts of functions and methods built onto charts that you can leverage. So if you set this as a main component kind of first-class citizen, later on in the component you can mess with it. So yep, var stack bar, and then set it later on. So not really global, but more universal to this component. So let's take a look at how this ends up getting. I just kind of walked us through this here. We're going to provide a UI for the users to show and hide teams. Same thing as before, only team-based. And we're going to make 2 different calls, one to our stack bar chart and another one to our aggregate chart. We're passing in the controller's data, and we're going to pass in a rejected list that is what the user is going to be toggling up here. So when they click on a team, it'll reject them from the data. And then finally, we'll add some stuff inside our stack bar chart component to make those work. So our update element will be called by rejected updated, and rejected updated observes rejected at each, which basically just kind of gives us an array. Anytime there's a change made to that array, update our component as needed. And we actually have this up data filtering. Cool. So this is actually D3 for the first time so far. And this gives us basic bar chart. If we want to, we can turn on and off strikeouts, runs, just look at hits. But more importantly, one of the things that we're doing in Ember now is giving the user the ability to control things. So if we don't really care about how the catchers did, we can turn them off. Or if we don't care about the infield whatsoever, we can turn them off as well. And what you should notice is, in addition to that top bar chart changing, the bottom one is as well. This is reading team totals all together. So you highlight over a team, you'll see how well Detroit hit, how well Boston hit, so on and so forth. So that's kind of the gist. If we want to eliminate even the National League, we can take them right out of the equation and only look at outfielders for the American League, which is kind of cool, right? We're changing something in Ember and having that pass down into our controller. And our controller is updating an array called rejected. We have an at each observer on our components, and every time that array gets changed, our components now update. So that's kind of what we want to do, and that's in a lot of ways kind of the holy grail of D3, right? And reusable charts in general. Change something in one place and have it propagate multiple times. So that's kind of fun. And again, you guys can go online, play with this right now, and you can manipulate the data however you like. Sweet. So we're able to create pretty sophisticated data visualization with no changes to our source data and relatively little code. The aggregated chart required a little bit of underscoring to use .group by. So that just kind of helps us say, look at the totals for this team versus that team. But otherwise, our data didn't really change, and we're basically passing in the exact same data array to both components. It's just handling it different ways. But we want to do a little bit more. I touched on this a little bit earlier, but there are some things in D3 that aren't just possible, or some things that D3 does that aren't really possible with HTML and CSS. Things like charge and gravity. So for the last chart I want to show you, I want to switch from. Oh, sorry, actually, I meant to show you this here. Hey, one more thing that I can do is this right here. Right now we're showing it as a bar chart. I can actually pass in something from Ember that tells me I would like my view to change, and it will update with it. So if I click on area, it'll take the exact same data and just kind of present it in a different way. It doesn't have to pull anything new in. The component just kind of reacts to it in a nice new way. So this is data observing state. Sorry, let's get back to it here. So the ability to switch from bar to area reflected what I'm about to show you briefly. But I'm going to show it to you in a little bit more robust way. And we're going to use force-directed graphs. Another show of hands, who's ever used or knows about force-directed graphs? All right, not a ton of you, but this is going to be pretty cool. I actually put it up online, and we're gonna walk through it really quickly. So relative to the other charts, this isn't really showing us any particular data that's bound to the American League Championship Series, like what we just looked at, which is good because I was getting depressing as a Detroit Tigers fan. What we're going to do is give the user control of two different rough categories of things. The first thing they're going to be able to do is coordinate how these elements kind of group up. And you'll see what this looks like here. Right now, they're set to mingle, so they all just kind of sit in the middle. Each one of these, I think 100 nodes, is generated in D3 on the fly. So that's not being grabbed from our data or anything. But right now, we're telling it to mingle. We can organize it by team and just kind of tell that to pop up. Or I can kind of set up in a Fenway format, which is something I had some fun with at the airport yesterday. Which is pretty cool. You know, you can take these nodes and you're basically giving it, at the end of the day, an X and Y coordinate that tells it where to go. But D3's force-directed graph gives you a lot more tools than just that. You can probably guess by the fact that I have charge distance, gravity, and friction up there, that those are 4 easy ones to pick out. But there's also a thing in D3 called the tick, which is not a comic superhero, but is actually a countdown from when you go from the starting point of looking at this graph to where the X and Y coordinates will resolve to. So a really quick example, when I click, it's going to start a function, and then after X seconds, it's going to resolve to where those nodes need to get to. So it'll explode real quickly. Or if I do it a lot, it'll explode a lot. And they'll eventually come back to roughly where they were before. You'll notice that there's probably some slight differences, but they're roughly at the X and Y of where we expect them to be. And these things are all kind of controlled by D3. You know, the minute I hit click, they know where they're going to resolve to. The tick concept in force-directed just tells it to go out to where you need to go out to, and then over time, slowly draw back to your original position. That doesn't just work in the mingle format. We can do that once you're organized by team. They'll still regroup by team. You'll see that they kind of get mixed up a little bit, and they'll always just kind of come back home. Same thing with Fenway. And they all just kind of regroup. But if you try to track an individual node, say this one, you'll see first time I click it, it goes down to the bottom right. Next time it goes up straight up. So there's not like a predefined way that I'm doing those things. Just know that the nodes themselves are kind of figuring it out as you go along, which is cool. So let's start messing with stuff. If you have this stuff online, you can go and play with it right now. Just know there's a good chance that you're going to crash your web page if you give these too crazy values, which when I say crash your web page always sounds to a developer more like a challenge than like a caution. But I promise you, if you mess with friction, it will. And I think we'll do that right now, actually. Let's try to crash this page. So let's talk about the concept of charge. And let's go back to a pretty simple view to see how this kind of works. Charge by default, all these right now are the default settings that D3 gives you. Charge is basically how much does each node hate the other nodes. So if I make this value go down, you'll see they want to try and repel from each other pretty hard. Or at the very least, they're trying to get away from each other a little bit more strongly. As I go up towards 0, they're pretty chill. You know, they're pretty cool with hanging out. Maybe they watched TV together on Friday nights. And if I say charge distance, we can set that to go a little bit higher. And this is going to max out at a percentage of charge. So if I go, no matter how far I go beyond like 400, it won't really care too much. And the smaller I go, the more cool they are with each other. And the ones that I really like playing with a lot, and you know that's probably related to the fact that these are the ones that tend to break the browser, are gravity and friction. So gravity works kind of the way you expect it to. in the force-directed graph that I'm showing you right now, everything is drawn towards the center. In Fenway, it's drawn towards a baseball park. And in organized by team, they're drawn towards 4 different quadrants. When I tell gravity to not be 0.1, if I set it to 0, it's going to not care about where those things resolve to. So we'll very quickly knock that down to 0. And now they're chilling out pretty good. This will eventually take them as far away as they want to go. You know, the higher I make that number, the closer they want to get, the more we impact them with gravity. And if I set that to a negative number, it's like they're in space. And they always come back together if I tell gravity to be above 0 again. But that's how gravity affects this. And friction is probably conceptually where you think it would be too. It's how much, when they come in contact with another, how much it's going to bounce them off each other again. So right now, if I click it, they come in contact with each other, they bounce pretty far. But if I set friction to be all crazy like, they start getting pretty angry. So this is friction set at 1, which means they'll never actually come to a stop, and you'll see it come to a stop, so I'm lying to you. But they'll never really come to a stop unless D3 says, hey, this will never resolve. I need to stop doing this, otherwise you'll crash the browser, which I promise we'll still do. Yeah, so this is kind of saying, I want to come back to my original place, but every time I kind of come within orbit of the other nodes, I'm going to keep flying around. So that's friction of 1. But you know, that kind of leads to the question, what happens if we go to a negative amount of friction? Yeah, now we start having some fun. And the further I make this negative, oh, I already ruined it, actually, sorry. That was supposed to be like a big lead up to that. I'll just refresh. But the further I make that negative, the more they want to bounce off each other and give each other like a really insane amount of charge. So you see this little module right here that if this was a real object and you saw it in real life, you would never want to come in contact with it because it looks like it's going to explode on you. Which it actually will. So you see all sorts of just crazy stuff happening. These same principles are, you know, kind of are arrived at as I move to the different views too. So let's take something like friction and or gravity even, and say that gravity is really tight packed. If I change to Fenway, our baseball field is very small, so something like what a little leaguer might play on, or organized by team is really tight knit. So I'm changing basically Ember controlled elements up at the top that are being reflected in 3 different views of a single component, in this case a D3 chart. So abstract concepts in Ember become very real physical properties inside of D3. And that's pretty neat. And what's even neater, I think, is these are all different pages on different routes in Ember. I can click over to, I can set that to Fenway, and if I click over to our basic bars example, and then I click back to it, you know what, that didn't actually, oh, sorry, yeah, it did. We stayed on Fenway. I can tell these to stay as well if I want to, but we basically had a controller setting that D3 obeyed the minute that we got back to the page, right? So I left the route, I came back, something had set over to the component, and it kind of reflected that change when I got here. So that's pretty fun. So that's how you give users control using the tick, and that's how I do data visualization with Ember components.